Since I read the book The Body Language of Trees by Professor Claus Mattheck, I've had my attention on harp trees. These are trees which fall over, usually a root ball failure, but they retain sufficient attachment to the ground to keep growing, to reorientate, and then in many cases also to reiterate, which basically means that the trees stand back up. Quite a dynamic thing, but something that we don't see as much of as we should, because people tend to crank up the chainsaw and cut fallen trees up. Yet there are families of trees and species of tree which appear adept at transitioning from fallen to standing. In cases I have seen, such trees may well not even have their lifespans reduced. So then in 2017 I was working on a project in Vanuatu, and I discovered an astonishing tree which had not just fallen over but stood back up and fully generated its body over its original fallen body, to the extent that it didn't look like it had ever fallen over. So this sort of led me to write an article, and it was a study of a number of harp trees that I'd gathered data on over the years, including the Vanuatu tree. And that's brought me to the point where I have quite a large body of work, and that culminates with this latest recording. Alright, this is Cassian Humphreys. I'm here just outside Bridgetown, Western Australia. Just pulled up on my trusty steed. There you can see my particularly handsome DR650. And I'm just about to walk into a field. I've had there's a tree there which I've had my eye on for a while, and it exhibits some really fantastic traits. So let's go for a walk. Because of background noise, I had to delete my original recordings. But so here we are, tracking across the field to a marigum, Corymbia calophylla. And you can see a grazing line around the perimeter of this tree. Livestock have cleared a grazing line, which has made it easier to actually study the body of the tree. So coming in, on the back left-hand side, you can see the upended root plate, which has since been fully occluded by tissues that have generated over it. Bear in mind that trees are like Russian dolls. They grow new tissue over old. One of the things that I consider when I look at trees like this is to think, let's say 1 tree in 1,000 is to stand back up based on the limits that humanity presents. Well, imagine if humanity was to encourage these trees to stand back up. Maybe it would be 1 in 100. As an arboriculturalist, that's a major focus of mine. And I'm going to be running workshops to teach people how to accelerate the process to help trees to stand back up. So a core observation that I've made with the harp tree studies I've done is around about at least 10 to 20% of the tree's root system needs to remain attached for the tree to be able to harvest sufficient water to support itself to stand back up. And there are 2 ways that trees are adapting. In one case such as this, the tree's crown reorientates itself, whereas in the case of other trees that we'll see in this study, some trees reiterate. So a tree's crown which reorientates is pretty simple, really. The leaves, the twigs, the petioles, they reorientate, and then minor branches will reorientate so that the tree's now catching sun in a prone position. Whereas with a tree which reiterates, new buds are formed, new shoots which turn to leaders, which grow straight up and give the appearance of the tree looking a bit like a harp. So walking in on the tree here, we can see the grazing line, we can see the exposed crown structure from the livestock, and we can see the back end of the root plate. The root plate itself is, as I said, has sustained at least 20% attachment, and the tree has generated new tissues over the original exposed root ball, which is washed away, and pretty much has closed, any sign that the root plate had been upended or exposed. And we can see that the tissues are kind of modifying into stilts. So there's sort of three key stilts that we're seeing here that were, horizontal roots, but that now they're sort of growing vertically, so to speak. We can see one old root sticking up skywards. That root was shorn off at the time of failure, although I can see a large portion of it is actually still alive, meaning that it's still having water allocated to it, including photosynthetics in the form of sugars. It would be useful to this root and therefore the tree to actually encourage it to produce shoots, so helping to supply more energy to this portion of the root plate. Drawing on arboricultural practices, this is something that we can do for trees like this. One of the things that I'm always looking for with harp trees is evidence of root generation from crown structure which has touched the ground since falling. I can tell from tree body language when this occurs. Here we have an old branch which is running along the ground, which I believe actually has rooted. To prove that, I'd have to do some investigative work. Though in the case studies that follow, the evidence speaks for itself through the body language of the trees. Here we have evidence of cavitation extending from the root plate up into the trunk of the tree, which the tree is occluding. And then looking at the tree's crown itself, we can see what were horizontal limbs which have adapted to being vertical. Incidentally, the word occluding or occlusion describes closure, where wound closes over an old injury, such as this knob, which was a former snag. Moving up the body of the tree, we can see where an old limb has made contact. The bulk of it has died, but there's still living tissue at its end. It's at this point where a grafting point to ground can be made. Such a transition may be difficult for a tree, but can easily be accelerated and supported by carrying out arboricultural support. Fallen trees like this, or harp trees, are perfect candidates for kindergartens. Fantastic shade trees for children to have access to. Coming back to the former root plate, here we can see the closing cavity, a root which is growing straight down, corresponding with the old root snag which is still pointing up. Before long, the layperson wouldn't even know this tree had fallen over. So moving on from a tree which has reorientated its crown, we meet a tree which is in the process of reiterating its crown. I couldn't miss this opportunity. So we've just come from a harp and noticed another harp. Check this one out. So this tree is a jarrah tree, Eucalyptus marginata. And here we have a relatively recent failure. Let's have a closer look. Well, this is interesting. There we have similar amount of root system that remained attached to ground, somewhere around about the 30% mark. On the other side of the tree, we can see a fairly major transport root that popped out of the ground. You can see the furrow that it made in the soil. But going in closer, and there we can see a pretty good view of the root crown. Not much root ball was attached to this. This was essentially sort of shearing at the root crown as opposed to root ball failure, although there is a measure of soil still attached. Looking at the top of this segment, we can see a hole where a root was broken out, and then running down we can see an adjacent root which is delaminated, shearing the root in half. Where the root breakout occurred, there's evidence of a brown rot. So originally what we had here was two standing stems with an inclusion between the two stems. The two stems weren't really joined at ground level. There was no graft union between them, so they were almost like two trees standing side by side without having any connectivity. Naturally, this led to the failure of this stem. Had I been able to initiate a graft union here, this tree would not have failed. Hopefully this tree is going to be left. So walking down the trunk, we'll get a bit of a view on the... Okay, yeah, this is a fairly recent cut, so I would suggest that this tree fell over probably within the last 3 months. The tree's fallen, the upper crown was removed, which is kind of a bit of a shame, but when we consider how close we are to a tennis court, I can understand why that was cut. But, a log like this has still got a huge amount of energy in it. And it's with stored energy reserves that this new shooting that has been produced is occurring. So now we're moving into the reiteration story. Here we can see a group of new shoots. These were formed by either dormant or floating epicormic buds. And these shoots are the tree's backup. We have stored energy within the log, but if the tree cannot generate new energy, then that log will become depleted and it's going to die. So these are the tree's backup energy reserves. Leaves are a tree's solar panels. And, considering the success of the marigum that we came from, there are many species of gum, eucalyptus and corymbia and Lophostomen, which are very good at making such adaptations. So what the tree is going to be banking on is stored energy, and then with a sufficient crop of new shoots, new leaders, new limbs, the tree will transition into a harp with a reiterated crown. And here we can see a very young shoot, maybe a dormant bud, but she's shooted, and as long as that makes sufficient growth and is able to photosynthesize, then these shoots are feeding energy into the main trunk. And where that fractured leader has been driven into the ground, there actually is the capacity for root generation, and for that to become a rooting point. And I have seen this in a number of harp trees in the past. So just giving you a perspective on the upper crown, the top of the tree. And then yet more shooting on these limbs here. Hopefully, if I get to come back to Bridgetown in the near future, I can follow up on this tree. Now, what I would be inclined to do if I was able to put the input into this tree is set up the parameters to it to help trigger or induce shooting on the main trunk. This may still happen. This is a recent failure. And there we can see the top of what's known as the inclusion. This is just where bark had rolled in on itself in between the two stems. Because of the inclusion, because of the ingrown bark, there was no interconnection between the two stems. There was no kind of grafting. To give perspective on what a natural graft union between two distant stems looks like, I reflect back onto this case study. Just wanted to acknowledge, and from another perspective with, codominant stems such as this, I've got a whole body of work going back even before 2008 of examples of trees that have formed natural grafts between stems, between codominant trunks. And this is another thing that we can do, as well as help a tree to generate itself into being a harp tree. We can actually induce natural grafts, bridge grafts between codominant stems. I mean, such a treatment, the inducement of natural grafts between stems would prevent this kind of a failure once sufficient graft is formed. This is one of the great things about the species Eucalyptus, Corymbia and Lophostomen. They all come under the being gum trees, also Angopha as well. They're all exceptional trees at optimizing or adapting by the use of grafts. So just in closing on this piece, just wanted to acknowledge, consider the amount of carbon in that log, and consider the amount of carbon that will remain attached to earth if that tree makes it back into full health. And considering the amount of root that's connected to the ground and that shooting, if the tree keeps it up, she'll be standing back up in no time. So our next case study is another tree which is reiterating following failure. This is an East Coast tree which has fallen and got hung up in a roadside tree. This looks like Eucalyptus grandis, but you can see where it's partially hung up, so it's a partial root ball failure, at least 30% still attached, and you can see the shooting running along the stem. As a point of interest, it would actually be viable to set up a graft union between this fallen tree and the tree that it's fallen into. So this is a classic example of a harp tree. You can see where it gets its name. In a future Treecast, I'm going to go into some more detailed discussion on epicormic shooting and the growth that trees make. So moving on up the highway, I came across this beauty. This is another marigum. This species features a lot in my podcasts, not just because its region, but because it's such a tenacious tree with some exceptional characteristics demonstrating, the true tenacity of the species. For a tree to be uprooted in the extreme drought conditions of Australia and to then make adaptations, this is an exceptional feat of biology and bioengineering. This truly is a phoenix tree. This genus, this species, is very much a phoenix. Grows new trees out of old. From this angle we can clearly see the tree's original reorientated crown and then the reiterated crown. It's interesting to note that the tree is putting more energy into its reiterating crown than its original crown. This is the common thing that trees do all around the world. In this case, I would advise the tree would be better to put the energy into your upper crown for the sake of balance. Though it could be considered that the tree is retrenching resources from the upper crown to reduce load on its upended root plate. Looking at the reiterating end of the tree's body, I've noticed a commonality for harp trees where they're close to the failure point where the root plate is lifted. The production of a shoot turning into a leader, very close to the base of the tree, as with this one, and it's obviously a key strategy to help energize the tissues directly around the root plate, whilst the tree is in transition from shifting from using 80% of its root crown to having to run off 20, and for a decay patch to initiate at this spot, that would have bad ramifications on the tree's future. So it's important to keep this energized. Zooming in on this epicormic shoot turned leader, we can see how over time this has thickened. Since being a shoot, who knows, this could be up to 20 or maybe even 25 increments of wood that has been laid down as foundation to this leader. Likewise, this portion of the tree's crown is a reiteration. This may have already been an established limb, which subsequently produced buds, shoots, and has reiterated. Though, as we pan in closer, we can see there's a real cluster of branches here. A biomechanical problem that harp trees have to overcome with reiterating crowns is twofold. The first is where dormant buds grow out of established tree trunks, and the second is where limbs grow on right angles to the now horizontal trunk. Called elbow limbs, this kind of crown structure must adapt through thickening or laying down wood to succeed. Reorientated crowns fare better when subject to wind load. Buds and shoots which form out of main trunks like this are known as epicormic. This is Latin for upon the stem. Buds and shoots which are formed normally are called endocormic. Endocormic is Latin for within the stem. Therefore, tree crowns which reiterate succeed through transition, and they achieve this by laying down sufficient increments of wood, subject to length. Coming back to the tree's upended root plate, we can see that the tree is now resting on what was a vertical limb. This makes up a portion of the tree's crown which reorientated. This makes for an interesting study. At the portion that the tree is resting on the ground, based on the body language of this branch, I can see that it's rooted. So, in essence, this branch is drawing directly on water from the soil. Zooming in on the connection point shows us the swelling at the point of attachment. This is where a root has grown and expanded and laid down increments of wood, therefore thickening that attachment point. Initially recorded by the science of Dr. Alex Jargo, it's by no means is it unheard of or even unusual for trees to be able to make these kinds of adaptations, but in actual fact it's not really that common. I believe it would be far more common if we humans, if we people were to actually assist the process. But that would involve decompacting soils, that would involve aerating soils, that would involve irrigation, and in an advanced arboricultural capacity in helping to actually induce rooting. To really be in service to trees, we need to be proactive. Panning in now, I'm just looking at areas of the root crown where there's swelling or buttressing, indicating growth since failure. And I can see at the center of this slide such evidence. Likewise with this region of the tree's root crown, you can see swelling from the trunk down into the soil. Swelling such as this are essentially guy lines helping to anchor the tree back to the soil. And this kind of evidence is validation of the success story that the tree has made since falling over. What an honor it is to make observation of trees like this and to be able to record them for posterity. Because let's face it, generally speaking, no one's really talking about these kinds of success stories. With a lifetime in arboriculture, I truly have become indebted to the tree. In this final segment on harp trees, I'm going to do a study on a tree which has had a lower limb be rooted to the ground. This is one of the best examples I've seen since I've been in Western Australia.